So I'm going to work through some practice problems from the electron configuration practice worksheet number 2. This is starting to probably get like you're doing a lot, but as you're doing more and more of these practice problems, the easier and easier it gets and the better prepared you will be for our test for the end of this unit. I actually think I want to start with the problems on the back first, because these are your first and only practice problems of writing orbital notation. Okay, so this is us filling up the electron cloud hotel. As you can see, I've given you the boxes that will represent the different orbitals or the different beds within each one of these sublevels that I've identified. Okay, one thing I will let you know is that you, on your test and on your quiz, you will need to write the 1s, the 2s, the 2p, the 3s, the 3p. And don't be afraid, that is just the order that it takes for you to fill up each one of the spots in your periodic table to get to whatever element I'm asking you to do the configuration for. Also, keep in mind, because of the off-ball principle, the electrons fill up the lowest energy levels first. But if you want, I've had kids before find atomic number 8. We know that to be oxygen. And then they can actually write the full electron configuration starting with 1s2, 2s2, and then they can map how many electrons they've put in each one of those orbitals according to their full electron configuration notation. Okay, let's get started. So we know that atomic number 8, that is oxygen, so it has a spot for you to write oxygen. And we know that neutral oxygen, they did not say an oxygen ion or anything like that. He's got 8 electrons, so I should see 8 arrows in some way in your orbital notation diagram. So we know that oxygen is going to be, start at 1s2. So I would go 1s, 2, so 2 electrons. And in fact, I'm going to go ahead and write the configuration, I feel like, up here real quick. So 1s2, 2s2. To get to oxygen, I would go 2p4. Okay, so hopefully you're tracking that we would get 2p4 to represent those 8 electrons from oxygen. So I've got to stop myself once I get to the 2p room and only put 4 electrons in there. So we have our 1s2. We now move to our 2s. And now we hop up into the 2p room and we're only going to put 4 electrons in there. Once again, everybody takes an empty bed, and once again, all of these boxes represent the p room. And if you look up here, all of these 5 boxes represent a d room. Okay, so that was an example for oxygen. I'm going to hop over to this next one, atomic number 10. Who is atomic number 10? That is neon. So atomic number 10 is neon. He has got 10 electrons. Okay. I can write his configuration, or I can just look at the periodic table and fill in as I'm saying, which I think I'm going to try to do now. So 1s2, which means that looks like that. And then 2s2 to get through that. And then for neon, I stop in the 2p room. I go 2p all the way through 6. So all of these beds are going to be filled with 2 electrons per bed, but I want us to make sure that we're demonstrating how they fill up. So 1, 2, 3, and then we double up 4, 5, 6. Okay. Now we're moving over. Let's do this one. Cobalt. Cobalt is atomic number 27. So we're going to do cobalt. He's got, sorry, y'all can't see. He's got 27 protons, so he also has 27 electrons. Sorry, my brain just started to have a meltdown. Just a random, short-circuiting. Okay, so to get to cobalt, I go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, then 3d7. So those electrons will be filling up. When you've got big or bigger elements, you can kind of blast through the hotel very quickly and then start slowing down when you get closer to where you're supposed to end up. So 1s2, 2s2, then 2p6. So up, down, 3s2, up, down, 3p6, up, down, 4s2, up, down. And then 3d, we said we were stopping at 3d10 or 3d7. Told you my brain is melting down right now. So we would go up for the first 5. We've got 2 more to put in here. So down. Cool. And you can always go back and count the arrows and make sure you're getting the 27 that we wanted. I'm going to do what am I going to do? I'm going to do the calcium ion down here. So atomic number 20, he's calcium, but we got a positive 2 charge. That positive 2 charge, cat ion. Cats are losers. He has lost 2 electrons. So we are not going to be doing 20 electrons for a neutral calcium because neutral calcium is atomic number 20. We are going to do two less than that. So that is 18 electrons. Okay. So 18 electrons, and we'll see if we can kind of map out how those electrons, being now an ion, are going to be slightly different than a neutral calcium. Regardless, I've got to get eventually down to 4s. So once we get closer to 4s, we will start thinking about what we are going to do to accommodate this ion situation. So 1s, up, down, 2s, up, down, 2p, up, 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 down, 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 3s, up, down, 3p, up, 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 down, down, down. Okay, now we're getting closer to 4s. Neutral calcium would be 4s too, right? But I'm telling you that he's lost 2 electrons. Well, he's going to lose them from that highest energy level, that fourth one, that fourth S room, and both of them. So I actually don't have that. Those 2 electrons that I would put up here if he were neutral are now going away to make him an ion. Okay, last one real quick is I am going to do this one. So symbol is bromine, but oh no, I gave you a -1 charge. That means he has gained. I broke my pencil. Gained 1 electron. So neutral bromine would totally have 35 electrons, but he now has gained 1, so he is 36. So I will actually be adding an extra arrow onto my configuration than I would have if he were neutral. So bromine looks like he is stopping 5 places into the 4p room. So I will go, when I get to 4p, oh my goodness, this is going to be quite a lot. That is fine. So I'm going to be going 1s up, down, 2s up, down, 2p up, 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 down, 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 3s up, down, 3p up, 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 down, down, down. 4s is next, up, down. I keep breaking my pencil. And then 3d, because after the 4s room, we run into 3d. So I'm going all the way through the 3d room to get to bromine, right? So I go 3d, 10, which means I go up, 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 down, 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 down. And then my 4p situation, keep in mind, don't just go 5 without thinking, because we have gained an electron. He is not looking like a neutral 35 electron guy. He is looking like somebody who has now 36 electrons. We'll be writing configuration for something that looks like krypton, because he is isoelectronic with krypton. So that will completely fill up the 4p room, which means my neutral bromine would look like that. But now because he is an ion who has gained an electron, he will look like that. Okay, I want to do a couple from the front page. I know we just immediately shot over to the back page, and that is super fine. A couple more of practicing some of the noble gas configuration ones, and maybe practicing some of these charged guys over here, just getting really warm and cozy with adding or gaining electrons and how that alters our configuration. So let's do actually these 2, number 5 and number 6. And then I want to do number 9, writing noble gas for nitrogen, and then writing noble gas for uranium. And then I want to do maybe the first 2 on the last section, which has us figure out what element we are trying to find by looking at what the configuration is. Okay, so here we go. Oh my goodness. Okay, so we got potassium, who has a +1 charge. Let me focus. I feel like I am out of focus. Cool. All right, so potassium is a +1. Neutral potassium is 19 electrons. +1 means he has added, or lost an electron. Lost 1 electron. So he is looking like he has 18 electrons. You guys, I've been doing so much configuration, I feel like I am losing my mind. So he's looking like he has 18 electrons here at this point. Okay, so if he's looking like he has 18 electrons, he is looking like argon. So we will write configuration for argon. So we are going to go 1s2, 2s2, 2p6. So to map ourselves out to see where we are on 2p6, right? So we've got to go down to 3s2 and 3p6. Because this potassium has lost an electron, he does not finish off with his normal neutral 4s1. That 4s1 electron has gone away. Okay, which means my valence electrons, outermost s and p, 2 plus 6 is going to be 8. So then I have phosphorus. Phosphorus is right here normally has 15 electrons, but this charge of a -3 means that he has gained 3 electrons, which means phosphorus neutral 15 electrons plus 3 means he has 18 electrons. 18 electrons, just like that potassium ion. They're isoelectronic with each other. They are both attempting to look like argon electronically. So we will be repeating the configuration we just wrote. 1s2, 2s2, 2p6, 3s2, 3p6, which means I also still have 8 valence electrons, okay? These guys, once again, they are isoelectronic because both have 18 electrons. So that's 18. Okay, do a couple of noble gas guys down here. So my noble gas guy of nitrogen. So nitrogen, let's find him. He is atomic number 7. He is not a charged atom, so I will be representing him with 7 electrons. But I'm doing his noble gas notation, which means instead of going at 1s1 and going all the way to nitrogen, I'm starting at the noble gas behind him, and that is helium. So I would go helium, and then from helium, I drop down and I hit 2s2. And then nitrogen is 3 places into the P room. So we got 1, 2, 3 places into the P room. So 2p3. So for my number of valence electrons, the outermost energy level, which is the second energy level in this case, the S and P electrons from that energy level, my valence electrons are 5. Uranium. So as you can imagine, uranium sounds like it's a big element, and you guys, he totally is. He is, wow, he is atomic number 92. So we got a long way to go. I'm going to zoom out so I can see a little bit more of the periodic table. And we are going to be able to get a better idea of figuring out how do I map myself back to find that nearest noble gas behind him. You are grateful that I'm not making you write the full configuration, because starting at 1s1 would be very annoying, I feel like, at this point. So uranium, he's right here. So I got to backtrack. And you can always check the atomic numbers. You're just going backwards. So after 89 is 88, which means I go back into the 7s block. And then I go to atomic number 86. So radon is my noble gas behind uranium. So radon. And everything after radon means I go, after radon, 7s2. Hop on down to get to uranium. Yes, I am in the 5f room, and I am 1, 2, 3, 4 places into the 5f room, so 5f4. Valence electrons, though. Outermost energy level. It's not the 5th one. I got stuff in the 7th energy level. Hi. Okay, I don't have anything P, right? But I do have stuff in the S. So my valence electrons for uranium are 2. Okay, last 2 problems. I've given you the configuration. I want for you to tell me what element that is. Once again, all you have to really kind of do is look at the end of the configuration. Who is the guy that is the 4th place into the 3p room? Who ends at 3p4? Well, 3p4 is sulfur. 4 places into the 3p room. I would write sulfur. Or you can just write S. It does not matter. I can identify the element by its atomic symbol as well. Okay, this one, I've given you a noble gas notation. That's not a big deal. I'm still kind of basically looking at the end of this, but if that is helpful to you to figure out, okay, well, I'm going to be on the next row below Krypton, that's fine. I'm looking for the guy that ends at 5p3. So he's going to go through 5s2, 4d10, and he's going to end at 5p. So 4d10, 5p3. That's antimony or antimony. It does not matter how you say it. So that is antimony. Or the symbol for him is wacky, SB. So I think you guys have a lot to kind of chug along through. I would strongly suggest, if you have not already done yet, working these problems with a blank periodic table. I did not model with a blank periodic table for these lessons because I'm assuming if you're watching these videos, you maybe need that visual of our colored one. But remember, with our blank periodic table, the S block starts on the 1, the first energy level and higher. So you would be 1s, 2s, 3s, 4s, 5s. P block starts at 2p and higher. D block starts at 3D and higher, and my F block starts at 4F and higher. So when you start going through the sections where things kind of get jumbled up, you can kind of maybe reorient yourself and find what place you're supposed to be in. So I hope that was helpful, and happy electron configuring.